Good afternoon, everyone. I'm Shota Deolusegun. So we're going to continue from where we stopped the other time. I promised that I'm going to use classical mass worth to retrieve I'm going to use the quantum mass worth to retrieve the classical mass worth of 86 kilogram. So that is what we're going to do today. And also we're going to use the magnitude of the wave of electron to get what value of electron we can get when it is in motion. So those are the two things we're going to do today. Come with me. Now here is the formula, which is the dt dm equal to capital Um plus 4m. So right now we're going to substitute the the quantum mass worth into the formula. We have the constant, our regular constant, which is 2.5 times 10 raised power 39. Then we open brackets. We now have the quantum mass worth, which is 3.4 times 10 raised power minus 38. We close the bracket, then plus. We now have 4. Then we repeat the mass. So good. So now, by the time we multiply this, we're going to have this. When we multiply, we have 85, then plus. Now this particular one, when we multiply, we're going to have 1 point. When we approximate 1.4, then so times 10 raised power minus 37. So when we add this, we have 85. Then we have 85 kilogram instead of 86 kilogram. With this, we say the 1 kilogram is being converted to it. So when the classical mass is being stretched at this particular interval, because of its position at quantum level, it is not being maximally optimized. So we have a part of it being converted to it. So 1 kilogram of the 86 kilogram, 1 kilogram out of the 86 kilogram is being converted to it. So that is how we can use the quantum mass worth to get the classical mass worth of the 86 kilogram. So right now we want to see what the mass worth of electron will be when in motion. Let's quickly do that. So we have our usual constant, which is 2.5 times 10 raised power 39. Then we open bracket. Now here we have if you still remember, the magnitude of wave in our previous calculation will be, when we approximate, will be 5.7 times 10 raised power minus 48. So then we have plus here, then we have 4. So then we repeat the mass. So good. So right now, by the time we multiply this, we're going to have we're going to have 0.0000000, then 1 So we have 1, then we have 4. We have 1 right here. So we have 1, we have 4, we have 2, 3. So now we plus. So by the time we multiply this, then we're going to have 2.277, then 5, 2 times 10 raised power minus 47 here. Minus 47. Good. So when we now add this to it, we have, when we sum them together, we have 0.00000001423. So now we see that when electron is in motion, in that superposition, its length is very, 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 very tiny. You can see what we have right here. So the mass is reduced. So now if we should use the upper limit of the wave magnitude for the classical mass worth in motion, that will be, it will increase because it's going to be inverse of the quantum mechanics. So there is reduction in mass at quantum level, but there will be an increment of mass at classical level. So that is that. Now we see how we see the worth of electron in motion, and then we see how quantum mass worth could be used to actually retrieve the classical mass worth of 86 kilogram. Now you can see the authenticity of this particular formula. Then there are some other things that we're going to look at too in the subsequent videos. I'm going to extend it to what I will still I will keep it a secret for now. Please like this video, share the video with your friends, then make sure you subscribe to this channel so as to be notified for the subsequent videos. Then I'm going to put the link to my research publication in the description below. You can click and then use the formula yourself to get all these values. Thank you. God bless you.